Welcome to the Explainer. Today, we're getting right into the exact metrics the SASB standards demand for managing coal tailings storage facilities. If you're tracking sustainability or risk in the coal sector, getting a handle on this specific 12-point framework is absolutely crucial.
Let's take a look at this quote right here, because it really hits the nail on the head as to why we're doing this. Mismanaged coal waste, impoundments, your fine coal refuse ponds, or tailings storage facilities, carry massive, and I mean massive, environmental, financial, and human risks. If one of these facilities leaks or, heaven forbid, suffers a catastrophic dam failure, the resulting contamination literally devastates local communities. And for the reporting entity, well, that translates directly into severe regulatory penalties, eye-watering remediation liabilities, and basically a complete loss of their social license to operate.
To unpack this standard today, we're going to look at the tailings storage risk, facility basics and status, engineering and capacity metrics, risk, review, and mitigation, and finally, emergency preparedness planning.
So let's jump straight into part 1, the tailings storage risk.
Take a look at this. This is the core requirement, SASB metric EMCO 540A.1, 12 specific columns of data. Now, at first glance, I know it might seem like just a massive administrative headache, but as we fill this in together, you're going to see how it effectively forces a company to prove they have a real, boots-on-the-ground grip on the physical reality of their waste storage.
Moving right along to part 2, facility basics and status.
So we start building out this table, and the first 4 metrics are all about establishing baseline accountability. You've got to name the facility or give its exact identifier and pinpoint its location, specifically the country of operation. Next up is ownership. Is the reporting entity actually the one operating the site? And lastly, for this section, the operational status. Is the site currently active? Is it inactive but under maintenance? Or is it fully closed down? Just the basic facts to set the stage. Next up, part 3, engineering and capacity metrics.
Here's where we start getting into the physical structure. Metric 5 requires defining the exact construction method of the dam. The standard looks for ICMM categorizations here, so we're talking upstream, downstream, or centerline. And this is absolutely critical. Why? Well, methods like upstream construction, where the dam is literally raised on top of the uncompacted tailings themselves, carry a significantly different risk and stability profile compared to downstream methods. Oh, and if a facility uses some completely different method, they have to log it as other and provide a really clear description of what exactly they're doing.
Okay, let's add metrics 6 and 7 to our table. These track the maximum permitted storage capacity right up against the exact metric tonnage of current tailings stored. Both of these have to be reported in metric tons, by the way. By placing that current volume directly next to the max permitted capacity, any investor or regulator can look at this and instantly calculate how dangerously close a facility might be to overaccumulation. It's a quick, hard reality check.
That brings us to part 4, risk, review, and mitigation.
Now, I want you to really consider this question for a second. Is simply recording that physical capacity actually enough to prevent a catastrophic dam failure? Well, the SASB standard definitely recognizes that having the data alone doesn't guarantee safety if there isn't rigorous oversight. Knowing exactly how much waste is sitting in a dam doesn't actually tell you if that dam is structurally safe today. For that, we need independent eyes and standardized hazard classifications.
Which leads us perfectly into metrics 8 and 9. Metric 8 requires classifying the potential fallout of a failure and doing so using the Global Industry Standard on Tailings Management, or GSTM. Basically, it asks, if this thing fails, exactly how bad are the consequences going to be? Then, metric 9 brings in the accountability piece. You have to state the exact date of the most recent independent technical review. And listen, independent is strictly defined here. It has to be conducted by third parties who have never been directly involved with the design or the day-to-day operation of that specific facility. No grading your own homework allowed.
So what happens if that independent review actually finds material safety issues? Well, the entity absolutely cannot hide them. Metric 10 requires a public black and white yes or no declaring if material safety findings were discovered. And if that answer is yes, Metric 11 immediately kicks in. The entity has to confirm whether they've implemented mitigation measures to reduce the risk down to ALRP. And ALRP, if you're not familiar, stands for as low as reasonably practicable.
Look at how our table is expanding now. These accountability metrics are what transform this from just a static, boring inventory into a living, breathing safety record. The standard is essentially forcing a direct, visible connection between the engineering limits, the timeline of those independent inspections, and the mandatory mitigations.
Finally, we reach Part 5, Emergency Preparedness Planning.
Metric 12 is the last line of defense. It demands a simple yes or no on whether a site-specific Emergency Preparedness and Response Plan, an EPRP, is in place. And to be clear, it is not enough to just have some general high-level corporate policy sitting in a drawer somewhere. There has to be a highly targeted plan for that specific location. This ensures that local stakeholders, public agencies, and first responders are fully prepared to minimize the fallout if the unthinkable actually happens.
And there we have it, our fully built 12-point matrix. By demanding these exact 12 data points, the SASB standard gives stakeholders a totally transparent view of a company's tailings management. From the basic identity, right through the engineering capacity and independent oversight, all the way down to emergency readiness. It honestly leaves very little room for a company to hide a poorly managed facility.
As you take away these insights from our explainer today, I want to leave you with a thought. Is the ultimate goal here just filling out this table so we can check a compliance box? Or is it about fostering the kind of deep, structural safety culture that's actually necessary to protect our ecosystems and our communities from a disaster? Because at the end of the day, the data is just the baseline. The action driven by that data is what truly matters. Thanks for joining me on this deep dive into the SASB Tailings Storage Framework.